Yeah, hello everyone, and welcome to this webinar. Today we shall be talking about a correlation. But before that, I want to expose you to what um, where correlation really emanated from. Of course, we call something statistics, and then here you we have inferential statistics is something that you can it's a function on you can use it on Excel. We have mathematical functions there. We have statistical functions on Excel. We have angular functions there. We have several functions on Excel, and but today we'll be talking about correlation, which is under a statistical aspect of Excel. So here we have inferential statistics to break it down, and he said inferential statistics is about observing a sample from a population and drawing conclusion from set sample. It is making inference from a sample of data. And population, what does it mean by population? Is the entire set of individual items or data points, etc., data of interest to a particular study. And the sample they are talking about is a subset of population. That is, out of the population in a state, we might have male and female. A sample can be for the male, another sample for the female. Is a subset of population, but the entirety of the state are the cumulations and the aggregations are the population. So and today we continue by uh, looking at the techniques in differential statistics. We have correlation, regression, t-test, ANOVA, z-test, and chi-quest scale test. Here you can find all this on Excel. And then continuing, we have p-value. Uh, to me, I call it point value. It is a statistical measurement used to validate an hypothesis. It is the probability that the observed value or result gotten was due to a random chance. Now they give an example. If p value, that is point value, is less than 0.005, then the test is statistically significant. But if the point value is greater than 0.05, then the test is statistically insignificant. We will get over there. When we get there using Excel, you will understand what this p-value really means. So today we want to go into hypothesis. I will be using an hypothesis today of somebody who gave a project that I got recently. It's a project, and it's a questionnaire project. So, and we, after the hypothesis, we are meant to carry out a correlation on the data set. Of course, with my own hypothesis, I was able to, we will be able to assume, because hypothesis is drawing your conclusion and assuming on your own results using your own digression. That is what we call critical thinking. One of the things clients will be paying for is your critical thinking, how you are able to diagnose your way to be able to bring your ideas, your digression into possibly visualization. If possible, you are bringing visualization and be able to for them to make an accurate profitable decisions. So hypothesis is an assumption made. Now listen, assumption. It is an assumption made about a population parameter, and we have two types. We have null hypothesis and alternative hypothesis. The null hypothesis is an assumption that is made with the hope of nullifying it. That is, if you are already doing your data set and you see that nothing is correlating, nothing is showing forth, there is no assumption that can be drawn, you can nullify it. It states that there is no significant difference or relationship between two variables. Two variables, when we get there, you will when we cross the line, you will get to know. Alternative hypothesis two, of course, it's contrary to null hypothesis, is significant. You can draw conclusions and get the relationship between two variables. Now, having said little about the hypothesis, we want to talk about correlation, which is one of the statistical techniques that we can use in differential statistics. So it is a statistical tool. Remember, correlation here is a tool used to determine the strength and direction of a relationship between two variables. Always remember two variables. So if you are given a data set of 3, you have to use your own digression to confer or infer your own variables so as to draw out your own conclusion. And the two variables must be quantitative data correlation coefficient, which must lie between -1 and 1 direction. When we get there, you will know how you can make this data set to be between -1 and 1 direction. So direction, when you talk of direction, what does it mean? In secondary schools, we were taught of graph. So when we talk of direction, now that I'm talking of direction, your mind should be striking graphical representation, right? So direction can be positive or negative. So correlation determines the degree of relationship between two variables, right? Now, let's move on and then draw our whatever for today. Now, this is the questionnaire hypothesis. The questionnaire hypothesis deals with it's about examination malpractices. And hypothesis 1 said, would there be any significant changes in teachers participating in examination malpractices if they are properly motivated? Strongly disagreed 65, agreed 25, disagreed 10. The hypothesis 2, would there be any reduction in students' involvement in examination malpractices if there are not, if there are no, if they are not involved? Sorry, that should be if teachers are not involved in examination malpractices. Strongly agreed, strongly agreed is 63, agreed is 27, disagreed here is 10, strongly disagreed. Hypothesis 3. Now, remember, we are looking towards two variables, but we now have hypothesis 3 in here. There will be no significant reduction in examination malpractice if teachers were motivated. Now, we now have 3 things now. Here we have strongly agreed, which is 21, agreed 19, disagreed 25, and strongly disagreed. So, what are we drawing from here? What are we drawing from here? We now have 3 hypotheses, but we need 2 variables to draw our conclusion. So we need 2 variables. We need 2 variables to draw our conclusion. And I will have, to me, hypothesis 1, hypothesis 2, we have teachers involved. I will call hypothesis 1 as teachers involvement in examination malpractice, TIM, and I will call hypothesis 2 student involvement in examination malpractices, SIM. Then the hypothesis 3 will be a complement, which I will call a motivational level. So without further ado, I will see this way. I will call motivation level, motivational level ranges from 19, okay, ranges from, let me specify what the number I can use it. Okay, I can say ranges from 0 to 25. So the level of motivation now is low, to 35 rather. So the level of motivational level is low. I can say teachers involvement in malpractices. We want to see if there is correlation between ranges from, which is hypothesis 1. Okay, we can use ranges from 0 to 65, right? 65, which is high, very high. Students involvement in malpractices ranges from 0 to 63, which we can call high. So now we want to take this to Excel and start interpreting our data from there. So let's open our Excel. And okay, I can call this one motivational level. Now this is how I will interpret this. I will love to interpret this way. Motivational level, okay, it's still low, but we can call it, the highest one is 35, which is high. I will pick it from 35, 30, which is still high. 25, which is still high. 20, I can call this 20, medium. 15, medium. 10, which is low. 5, which is low. 0, which is low. Okay, it makes this particularly will make us to have a 8 uh, variables now that we want to interpret. Now, okay, now this is what I mean by we have 8 and character that we want to work with. So for teachers involvement in malpractices, I would like to teachers involvement here. Teachers involvement here is the strongest is 65. I would like to put it this way. From the strongest, let's make the increasing rate by 5 or possibly by 10. Now let's do it this way. Let's start from the lowest, which could be, should we make it 0, 10, 20, 30, 40, 50, 60, 70. Then for the students involvement in malpractices. Okay. So for student involvement, it ranges from to 63. Let's start by saying 63, we can make it 0, 5, 10, 15, 20, 25, 30, 40. So here it's not necessary that, now let's move on. We have nothing to do again with. So now here we are. We decipher our data set and we are calling it correlation coefficient. Okay, so here we can decipher our graph. If you want to interpret here now, we now have two variables to me. I have teachers involvement and student involvement in malpractices. Now, how are we going to represent this one with a graph? A graphical representation. Firstly, before we do that, I want to remind you that I said that a correlation, the two variables that you are using in correlation, it must be quantitative data, and the correlation coefficient must lie between -1 and one direction. Let's see if these ones will be between -1 and one direction. Firstly, how can we determine that? We will go to what we call data. And here we see data analysis. If you can't find data analysis here, no problem. This is how you do it. You go to file, you click on option. Once you click on option, you go to your hardings. After getting your hardings, you see analysis tool pack here. You click on go. Once you click on go, you see analysis tool pack. You click OK. But once you do that, you come back to your data, you will see your data analysis. So for me, I will click on here and I will find this is a correlation to find whether this my data set is between 1 and -1. Okay, the range now, I will input my range, then the outputs, I want the output range to be here and I want it to be here. So I will click OK. Now we can see here that my is all of them is within the range of -1 and 1. This is 0.9, which is still which is still less than 1 but positive. So I can call this one TIM, call this one SIM, call this one motivational level for teachers, mood level, mood level, mood level for teachers, and mood level for students. Sorry, for students. So how can we represent this one with a graph now? Of course, we remember it's two variables that we are dealing with: teachers involvement in malpractice and students involvement in malpractice. So if we want to represent this with this graph, we want to see the relationship between it. And here we have to go to insert, and we have to we will insert whereby we have to highlight first, then we insert our plot graph, our scattered graph here. So once we are able to do this, let me put this one here. Once we are able to see this, we want to see whether there is a trend of correlation between them. Of course, we can see that there is a correlation, high degree of correlation between them. And then I will put on my trend lines. And this trend line is touching 1, 2, 3, 4, 5. 5 of the points. So we will know truly here that there is a high degree of correlation between students' involvement in malpractice and teachers' involvement in malpractices. So if you want to make this more visible, you can click on data label if you want. You can choose legend. I choose not to choose that. And you can say there is high degree of correlation between the two variables. Yeah, if you have gotten to this point, I want to congratulate you and thank you for watching so far. I would like to thank you for watching so far. And this, we can save this, and then I would like to save it and put in my portfolio. So next time we'll be talking about regression, and then I want to say thank you for staying thus far, and I will see you in the next video. Thank you. I want you to please subscribe and then share this video to as many as possible for them to, learn a bit from the quota I'm contributing today. Thank you. See you in the next video.